going to talk about universe and the Big Bang. So before starting this video, please like this video and subscribe to our channel for the future updates. Cosmic adventurers to a mind-bending journey through the wonders of the universe and the explosive birth of existence itself. In this space-themed video, we'll unravel the mysteries of the Big Bang, diving into the very fabric of space and time to witness the awe-inspiring origins of everything we know. The Big Bang Theory is the leading explanation for how the universe began. Simply put, it says the universe, as we know it, started with an infinitely hot and dense single point that inflated and stretched first at unimaginable speeds, and then at a more measurable rate over the next 13.7 billion years to the still expanding cosmos that we know today. Existing technology doesn't yet allow astronomers to literally peer back at the universe's birth. Much of what we understand about the Big Bang comes from mathematical formulas and models. Astronomers can, however, see the echo of the expansion through a phenomenon known as the cosmic microwave background. The birth of the universe. Around 13.7 billion years ago, everything in the entire universe was condensed in an infinitesimally small singularity, a point of infinite denseness and heat. Suddenly, an explosive expansion began, ballooning our universe outwards faster than the speed of light. This was a period of cosmic inflation that lasted mere fractions of a second, about 10 to the power of minus 32 of a second, according to physicist Alan Gough's 1980 theory that changed the way we think about the Big Bang forever. When cosmic inflation came to a sudden and still mysterious end, the more classic descriptions of the Big Bang took hold. This early soup would have been impossible to actually see because it couldn't hold visible light. The free electrons would have caused light to scatter the way sunlight scatters from the water droplets in clouds, NASA stated. Over time, however, these free electrons met up with nuclei and created neutral atoms, or atoms with equal positive and negative electric charges. This allowed light to finally shine through about 380,000 years after the Big Bang. Sometimes called the afterglow of the Big Bang, this light is more properly known as the cosmic microwave background, CMB. It was first predicted by Ralph Alpher and other scientists in 1948, but was found only by accident almost 20 years later. A map of the background radiation left over from the Big Bang, taken by the ESA's Planck spacecraft, captured the oldest light in the universe. This information helps astronomers determine the age of the universe. This accidental discovery happened when Arno Penzias and Robert Wilson, both of Bell Telephone Laboratories in New Jersey, were building a radio receiver in 1965 and picked up higher than expected temperatures, according to a NASA article. At first, they thought the anomaly was due to pigeons trying to roost inside the antenna and their waste, but they cleaned up the mess and killed the pigeons, and the anomaly persisted. Simultaneously, a Princeton University team led by Robert Dick was trying to find evidence of the CMB and realized that Penzias and Wilson had stumbled upon it with their strange observations. The two groups each published papers in the Astrophysical Journal in 1965. Big Bang Theory facts answered by an expert. We asked Jason Steffens, assistant professor of physics and astronomy at the University of Nevada, Las Vegas, a few frequently asked questions about the Big Bang Theory. Has the Big Bang Theory been proven? This isn't really a statement that we can make in general. The best we can do is say that there is strong evidence for the Big Bang Theory, and that every test we throw at it comes back in support of the theory. Mathematicians prove things, but scientists can only say that the evidence supports a theory with some degree of confidence that is always less than 100%. So a short answer to a slightly different question is that all of the observational evidence that we've gathered is consistent with the predictions of the Big Bang Theory. The three most important observations are: the Hubble law shows that distant objects are receding from us at a rate proportional to their distance, which occurs when there is uniform expansion in all directions. This implies a history where everything was closer together. The properties of the cosmic microwave background radiation, CMB. This shows that the universe went through a transition from an ionized gas, a plasma, and a neutral gas. Such a transition implies a hot, dense early universe that cooled as it expanded. This transition happened after about 400,000 years following the Big Bang. Is there any occurrence that contradicts the Big Bang Theory? Not that I know of. There are some issues that arise with the simplest model of the Big Bang, but those can be resolved by invoking a physical process that is still consistent with the basic premise of the Big Bang Theory. Specifically, the fact that the CMB temperature is the same everywhere, that the universe does not appear to have any curvature, and that density fluctuations from quantum mechanical predictions do not produce galaxy clusters of the right size and shape today. These three issues are resolved with the theory of inflation, which is part of the broader Big Bang Theory. When was the Big Bang Theory established? Who came up with the idea? Hubble was really the person who set up the observations. Evidence continued to mount, especially in the 1970s with the detection of the CMB. The term Big Bang was first used in the late 1940s by the astronomer Fred Hoyle. Eventually, it caught on in the 1970s. The Age of the Universe. Artists' illustration of the Planck spacecraft against a background of orange and red gaseous filaments and a bright white line across the lower part of the image. Several other missions have followed in COB's footsteps, such as the Biomeirang experiment, balloon observations of millimetric extragalactic radiation and G-physics, NASA's Wilkinson Microwave Anisotropy Probe, WAAP, and the European Space Agency's Planck satellite examining the CMB also gives astronomers clues as to the composition of the universe. Researchers think most of the cosmos is made up of matter and energy that cannot be sensed with our conventional instruments, leading to the names dark matter and dark energy. It is thought that only 5% of the universe is made up of matter such as planets, stars, and galaxies. What are gravitational waves? While astronomers study the universe's beginnings through creative measures and mathematical simulations, they've also sought proof of its rapid inflation. They have done this by observing gravitational waves, tiny perturbations in space-time that ripple outwards from great disturbances like, for instance, two colliding black holes or the universe's birth. According to leading theories, in the first second after the universe was born, our cosmos ballooned faster than the speed of light. That, by the way, does not violate Albert Einstein's speed limit. He once said that light speed is the fastest anything can travel within the universe, but that statement did not apply to the inflation of the universe itself. Was the Big Bang an explosion? Although the Big Bang is often described as an explosion, that's a misleading image. In an explosion, fragments are flung out from a central point into a pre-existing space. If you were at the central point, you'd see all the fragments moving away from you at roughly the same speed. But the Big Bang wasn't like that. It was an expansion of space itself, a concept that comes out of Einstein's equations of general relativity, but has no counterpart in the classical physics of everyday life. It means that all the distances in the universe are stretching out at the same rate. Any two galaxies separated by distance x are receding from each other at the same speed, while a galaxy at distance 2x recedes at twice that speed. The expansion of the universe. The universe is not only expanding, but expanding faster. This means that with time, nobody will be able to spot other galaxies from Earth or any other vantage point within our galaxy. We will see distant galaxies moving away from us, but their speed is increasing with time. Harvard University astronomer Avi Loeb said in a March 2014 Space.com article. So if you wait long enough, eventually a distant galaxy will reach the speed of light. What that means is that even light won't be able to bridge the gap that's being opened between that galaxy and us. There's no way for extraterrestrials on that galaxy to communicate with us, to send any signals that will reach us, once their galaxy is moving faster than light relative to us. The Big Bang Theory, becoming a household name. From left, characters Howard, Leonard, Penny, Sheldon, and Raj from the CBS show The Big Bang Theory sit on a sofa on the floor eating food. Running for 279 episodes over 12 seasons, the show The Big Bang Theory followed the lives of a group of scientists, which included physicists, astrophysicists, and aerospace engineers. The show explores the group's nerdy friendships, romances, and squabbles. Its first season premiered on September 24, 2007, and the show officially ended on May 16, 2019. As we conclude this mind-blowing journey through the wonders of the universe and the epic tale of the Big Bang, we stand in awe of the cosmic forces that shaped our existence. Remember, the universe's mysteries are boundless, and as we continue to explore the cosmos, we're reminded that our thirst for knowledge knows no bounds. So keep gazing at the stars, for who knows what astonishing discoveries lie ahead in the uncharted depths of space. Don't forget to like, subscribe, and hit that notification bell to join us on future cosmic expeditions. Until next time, fellow space enthusiasts, keep your eyes on the skies and your hearts filled with wonder. Safe travels, Wonder.